Hello, and welcome to 5-Minute Math. Today we are looking at the 6th grade concept of writing one-variable equations and inequalities. This is standard 6.9a, and we are using item number 30 off the 2024 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so what do we have happening here? We've got a bus, right? So I'm going to draw a bus. It looks kind of like this. And we've got people getting off, and we got people getting on. We got little windows. All right, so we can say that there were 31 people on the bus after 4 people got off. Okay, so there were 31 left. I'll say 31 left. And what I'm going to do is I'm just going to draw 4 people. They used to be on the bus. Now they're off the bus. All right, so there's 31 people inside the bus. There are 4 people that got off the bus. Which equation can be used to find x, the total number of people on the bus before? Okay, so our keywords are after and before. So if these 4 people, if we were to turn back the time and have these people come back onto the bus, right? Well, then it looks like we would be able to represent that here. Let's just say x is our total number of people before they got off. Okay. How many people are still on the bus? There's 2 parts. There's people on the bus and there's people off the bus. The people on the bus is a lot larger. Okay, so that's 31 left on the bus after the people got off. And then there's 4 people off the bus. So we could use this to show the relationship between the people on the bus after they got off and the people that actually got off the bus, right? 4 people got off. And so if you wanted to, you can say, well, 31 and 4, those are our 2 numbers, right? You can say x equals 35. And that would make sense, right? If there were 31 left on the bus, there were 4 off the bus, you put those 2 together, there were 35 people originally on the bus. Now, how do we represent this in one of these equations? Because you notice that all of these equations have a 4, an x, and a 31. So they're not even looking for the 35. We can use that as a check, actually. So how could I write what I just wrote down here? I could say, well, 31 plus 4 equals, and they don't give you a 35, so I'll just write x, right? So I see a plus right here, but that's not really going to work. Because if I substituted in this x with what we know it to be, 35, look what's going to happen. Does that make sense? 35 plus 4 equals 31. So even though when I originally look at this, I see an additive relationship, that doesn't make sense. It would need to have these 2 terms flipped, right? I need the 31 and the x to be flipped. So let's write fact families. Okay, so I can use fact family to say the other addition sentence is going to be 4 plus 31. Still don't see that. I can also write 2 subtraction sentences, right? You can always take your total, and then you can subtract one of the parts to get the other part, okay? So I can say x minus 31, right, is going to get you this 4. And if we substituted in this for 35, that makes sense. Or we could say x minus 4 equals 31. Substituting this 5, this also makes sense. And you notice that that's right there. Another way we could check this would be to just substitute in the 35 for all of these x's. Right? Does 35 over 4 make 31? No. Does 4 times 35 make 31? No, it does not. The only one that's going to work for us there is C. We already proved that D does not work. 35 minus 4 does equal 31. That's our answer C.